In this next set of videos, we are going to be talking about exponential functions. So an exponential function can be written in the form f of x equals b to the x power, where b has to be greater than 0 and b cannot be 1, right? So, and x is a real number. So let's talk about why b can't be 1. If I had 1 to a power, it doesn't matter what that power is, right? So x squared would be 1. Or sorry, 1 squared would be 1. 1 cubed would be 1. 1 to the 74th power would still be 1. So that's why b can't be 1. It would just be a straight line at y equals 1. So x can be any other number greater than 0, and x can be any real number. And we'll find in later videos that an exponential graph will either have this form or it'll have this form, right? So let's go ahead and start by evaluating some of these functions. So the first function is f of x equals 4 to the x power. So 4 is the base and x is the exponent. And remember, when we have f of 2, that means that x is going to be 2. So we replace x with 2, and 4 squared is 16. Same thing with f of 0. I replace x with 0, and anything to the 0 power will be 1. And lastly, f of negative 1, 4 to the negative 1 power. Now what do negative powers do? They take the reciprocal. So now it's 1 over 4 to the first power, which is just 1/4. Same thing with this example down here. So b, the base, can be any number greater than 0 that's not 1. So 1/3 is bigger than 0 and it's not 1. So fractions are okay. Decimals are okay. We're going to do the same thing. We're going to replace x with whatever the input is. In this case, h of 0. So I'm going to take 1/3 to the 0 power, and anything to the 0 power, still 1. h of 2. So 1/3 to the 2nd power. That means I'm going to square it. 1 times 1 is 1. 3 times 3 is 9. And the last one, we have 1/3 to the negative 3rd power. So the negative will take the reciprocal, right? So 1/3, the reciprocal would be 3 over 1, or just 3. So the negative took the reciprocal, but now I still have to take the 3rd power. So the 3rd power of 3 is 27, because 3 times 3 times 3 is 27. On this side, I want you to go ahead and try these examples. But on this bottom one, you're going to need a calculator, okay? So using a calculator to simplify those exponents there. Alright, let's see how you did. So the first example, g of x equals 2/3 x for g of negative 2. So we're replacing x with negative 2. The negative of that exponent takes the reciprocal. The reciprocal of 2/3 is 3/2. And that only uses the negative. Now we need to actually square it. So 3 times 3 is 9. 2 times 2 is 4. g of 0, replacing x with 0. and anything to the 0 power is 1. Okay, not 0, but 1. And then lastly, 2/3 cubed. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Alright, in the example below, we have p of x equals 10 times 2.4 to the x power. So we start with 10 times 2.4 to the negative 1 power. Now I would go ahead and use a calculator on this because of that decimal. So you should have some kind of exponent button that looks like x to the y, or y to the x, or a caret button. Any of those should work. So I'm going to start, we have to start with exponents. So 2.4, and then here's my exponent button. So to the power of 1, and I'm going to make it negative, and we get that decimal. Then I have to multiply it by 10. So this is approximately, oops, lost my calculator, 4.1, let's round to the hundredths, so 4.17. Alright, let's do the next one. 10 times 2.4 squared. So first we're going to start with 2.4. We're going to square it and then multiply by 10. So 57.6. And there you go. So now we can evaluate functions in whichever form. Just make sure you follow order of operations, and negative exponents take the reciprocal.